Alright, in this video I'm going to be looking at finding partial sums. So it says consider the infinite geometric series, find the partial sums, Sn, for when n is 1, 2, 3, 4, and 5. And we need to describe what happens to Sn as n increases. So as n gets from 1 to 2 to 3 to 4 to 5, what's happening to our sum? So here's kind of visually what's going on. If you want to find Sn when n is 1, so that means S1, that's just the sum of the first term. So you're just looking at that piece only. So S1 would be 2/3, and we're adding nothing else to it. What I'm going to do is I'm going to put this in a decimal form. Well, 2/3 is going to be roughly 0.67. And what we're going to do is we're going to increase the subscript n there, and we're going to see what happens to our sum as n gets bigger. Because it's an infinite geometric series, you know that by the ... at the very end. That means this pattern is continuing on. So if you wanted to know what S2 was, that's the sum of the first two terms. So you're going to have 2/3 plus 1/3. So 2/3 plus 1/3. If you add those up, you get 1. So we went from 0.67 to 1. So a pretty big jump in our sum there. And then this pattern kind of continues. So S3 would be the sum of the first three terms. So we're going to have 2/3 plus 1/3 plus 1/6. So 2/3 plus 1/3 plus 1/6. Now you could type this in a calculator. 2 divided by 3 plus 1 divided by 3 plus 1 divided by 6. Hit enter and you're going to get 1.16. So notice we made a big jump from 0.67 to 1, about 0.3 of a jump, and now we went up by only 0.16. So we're not getting as big as fast anymore. And we got to keep this trend going. We got to go to S4, which means I want the sum of the first four terms. So from here all the way down to 1/12. So I'm going to have 2/3 plus 1/3 plus 1/6 plus 1/12. When you add those up using a calculator, you're going to get 1.25. So again, notice how we're really slowing down. We increased by 0.16. This time we only increased by 0.09. So it's really slowing down. So S5 is going to be the sum of the first 5 terms. So we're going to take 2/3, 1/3, 1/6, 1/12, 1/24. 2/3, 1/3, 1/6, 1/12, 1/24. And when you add those up, you get 1.29. So you notice how as the n got bigger, we increased, but we really started slowing down. And we're really starting to slow down towards these upper 1.2 area, 1.25 to 1.29. So we're probably really slowing down. And what you could do is, if you really weren't sure what this is approaching, because it's going to approach a number, what you could do is continue this pattern on. So notice it goes 6, 12, 24. So the next term would be like 1/48. And then you get, like, after 1/48, 1/96. So if you really wanted to continue that out, you could. And if you added those two terms I added in, we're going to get close to 1.32. So what happens is this is going up, and it's going to start approaching this 1.3, 1.32 number. If you had somewhere around there, that would be correct. So what we're going to say is it approaches 1.3. And I think officially it's going to point roughly 1.33 is where it approaches, and it's never going to go higher than 1.33. So this is what we call partial sums. It has a little bit deeper meanings when you get to higher level math classes, but we're increasing. We're getting really close to that 1.3 mark, somewhere in there. So if you didn't come up with 1.33 exactly, that's fine. If you said 1.3, that would be okay too. So this is finding partial sums.